Hello everyone, I'm Dr. KHEIR-EDDINE and welcome to Mathematics 2 for the 2024-2025 academic year. So today I'll try to introduce you to the core topics we will explore in this course, which builds essential skills for fields like physics, engineering, and computer science. So let's get started. So here's an overview of what we'll cover in this semester. So we will see 5 chapters starting from matrices, systems of linear equations, and integrals and ordinary differential equations or ODEs, and we'll finish with functions of several variables. Each topic of these ones equips you with tools to model real-world and solve real-world problems, right? So let's dive into each one of these. Now, the first chapter we'll see is matrices. So a matrix is a rectangular array of numbers arranged in a specific way in rows and columns, as you are seeing in this slide, to represent data or linear transformations. Okay. Now, why we study them? So matrices are widely used in disciplines like physics, computer science, and engineering. So they are used to model complex systems and solve linear systems of equations, right? We'll see in the second chapter. Now, what we will study in this chapter, so we will first start with types of matrices, like square matrices and diagonal matrices. Then we will see basic matrix computations, like how we can add 2 matrices or how we can multiply 2 matrices, for example. Then we will introduce the concept of determinants and how we can concretely compute them. We will see also the inverse of matrices. An important thing that we will cover also is the relationship between matrices and linear maps in linear algebra. And we'll finish with the concept of basis changes, right? Next, or the second chapter we'll see is systems of linear equations. So a system of linear equation is a set of equations that are linear. Okay, for example, here you are seeing a system of 2 linear equations. So we have equation 1 and equation 2. So these kind of systems are often represented in a matrix form. In this form, for example, and you're seeing here, it's a matrix multiplied by a vector of unknowns equals to the vector of constants, right? Now, why we study them, why they are important. So systems of linear equations, they are also used widely in physics and engineering to describe relationships between physical quantities or variables in physical systems, right? Which is the case, for example, in motion dynamics in physics and control systems in engineering, right? Now, what we will see in this chapter, so we will first start with the matrix representation of a linear system of equation, okay? Which means that how we can move from this, this representation or this type of representation to this one, to this form here, which is the matrix form, right? Then we will see how the set of solutions of a linear system of equations should be, or how we can define them, right? And the third thing we'll see is how we can solve them concretely in practical applications. What are the methods that we will use to solve them? We will see methods like Cramer's method, the inverse matrix, and the Gaussian elimination method, right? Now moving on to integrals, which is the third chapter of this course. So an integral helps us to to compute areas and volumes, and also antiderivatives or primitives, right? Why they are so important? So they are vital in physics because they are employed in formulating physical laws, physical systems, for example, in fluid dynamics. They are also used to compute, as we have said, in computing areas, volumes, and surfaces, in physics and in engineering, right? What we will cover in this chapter, so we will start with the concept of indefinite integrals. We'll define them. We will see the integrals of usual functions, most simple functions that we are familiar with. We'll then see techniques that can help us to integrate functions like integration by part, reduction formulas, and also variable changes. Then we will move into much more complex integrals like the integration of polynomials and rational fractions, and also exponential functions, and trigonometric polynomials, for example. And we'll finish with the concept of definite integrals. We will define what is a definite integral and what are their application in physics or in real-world problems, right? Now we will move to the next chapter, which is the fourth chapter of this course, which is ordinary differential equations, or ODEs. So an ODE, or differential equation, or an ordinary differential equation, is a kind of equation that relates a function with its derivatives. For example, an example of this is what you are seeing in this slide. For example, here we have the derivative of the function y and the function y itself, and there is a relation between them. There is a summation between them equals to the cosine of x. This kind of equations that involve both the function and its derivative, they are called differential equations. Why they are so important, why we study them. So ODEs, or differential equations in general, they are used to model phenomena or physical phenomena, right? What this means. For example, an ordinary differential equation can model heat transfer, how this process, how this physical phenomena can be translated into a mathematical equation, right? Which is widely, used in physics, engineering, and also in chemical, for example, reactions. Yeah. So these kind of equations are omnipresent in every discipline, right? Even in biology, for example, right? Now, what we will study in this chapter, so we will first start with ODEs, like general definitions or preliminaries. Then we will see a special type of differential equations, which are the first order ordinary differential equations, which only involves the first ordinary differential equation, like the case here. So this ODE only involves the first order or the first derivative, right? Which means that this one is a first order differential equation, right? Then we will see separable differential equations, and how can this kind of equations be solved much more simply than other complex types, right? We'll then move into another special type, which is first order linear ODEs, which is again a differential equation that only involves the first derivative and it's linear. We'll define what we mean by linear. We'll see methods to resolve or to solve this kind of equations too. Then we will move into second order ODEs, right? Which are the differential equations that involves the second derivative. We'll see definitions and how we can solve them. And we'll finish with another special type, which is second order linear ODEs with constant coefficient. We'll see also the definitions and how we can solve them, right? Now, the last chapter of this course is called functions of several variables. So a function of several variables is a function that can admit more variables, or more than one variable, which is the case, for example, of this function here that involves x and y, both variables, right? We will see what or why they are important. So they are used in fluid mechanics, electromagnetic fields, for example. They are used in many disciplines in physics. What we will see in this chapter is how we can adopt the usual the concepts like limits, continuity, partial derivatives, differentiability from a function of one variable into these kind of functions. And we will see their applications, for example, double and triple integrals, how this kind of functions can help to solve this kind of integrals, and their applications in physics, for example, right? So that's a wrap of what I wanted to say. So thank you for your attention. I'm excited to explore these concepts with you in this semester. So any questions, feel free to reach out if you have any doubts as we progress. So let's make this a great learning journey. Thank you.